9.7 will continue with the quadratic formula. However, we will be talking about graphing quadratic inequalities. You will find many of the concepts are related to graphing linear inequalities. So, you will study the following types of quadratic inequalities. We'll have again the less than and greater than. We'll also have the less than and equal to or greater than and equal to. And the graph of a quadratic inequality would consist of the graph of all the ordered pairs that are solutions of that inequality, the x's and the y's. So, first of all, for example 1, we're just going to check some points. So it says sketch the graph of the equation y equals x squared minus 3x minus 3. So we went ahead and we did that the same way we have been doing. We would find, does the hyperbola go up or down? We would find its vertex, and we would go ahead and find some mirroring points. So then it says plot and label the points, and they're going to give us 3 points, a point A, B, and C. We need to tell whether each point lies inside or outside the parabola. So we went ahead and we did the sketch. Our second step then would be to plot and label those points, and then we can see A and B lie within the hyperbola, and point C lies outside of the hyperbola. This will be important when we are talking about solutions to an inequality. So, checking points help you graph quadratic inequalities by telling you which region to shade. You can use the following guidelines to graph any quadratic equation. You're going to notice that there are several steps that are exactly the same as they were for linear equations. We're going to sketch with a dashed parabola for inequalities that are just less than or greater than, and we are going to have a solid parabola if the inequality contains the equal sign. The parabola then that you drew separates the coordinate plane into two regions again, and we need to just test a point that is not on the parabola to find whether it is a solution of the inequality. If it is a solution, we'll shade its region. If not, we'll shade the other. Very similar. So let's go ahead and get started. First of all, sketch the graph of y is less than 2x squared minus 3. So because we have a less than symbol, we're going to have a dashed parabola, and because a is positive, it's going to be facing up. So first of all, we'll sketch that equation, and that corresponds. We're going to use the dashed line because it is a less than, and we're saying that the parabola opens up. Step 2 then would be that we would test one of the points. We're going to say the point 0, 2. So 0 either way, and we're going to go up 2. So that point is not on the parabola itself. That point is right here. We're going to see if that point is a solution or not. So we're going to go ahead and we're going to substitute the 0 in for x and the 2 in for y. So is 2 less than or greater than 2, 0 squared, that would be 0, minus 3 times 0 would be 0 again. So is 2 less than 0? 2 is not less than 0. So we will go ahead and let's see, did I continue that one here? Oh, it looks like I've done this one twice. So let's go ahead and sketch that. And then I'm going to write the original. This is for example 2. Write the original. We're going to substitute 0 and 2 in to see if it's true. 0 and 2 do not work for the x and the y, as we said. And since 2 is not less than 0, the ordered pair is not a solution. So when I go ahead and graph it, I'm going to make sure that the region inside the parabola is where 0, 2 is contained. Since that is not a solution, we will shade outside of the parabola. For example 3, we're going to sketch an inequality again, and it says sketch the equation y equals negative x squared, and I think we have, oh, we are missing one step here. Let's take that over to the side a minute. We're going to sketch the graph of y is less than or equal to negative x squared minus 5x plus 4. So first we're going to change it into an equality, and we're going to sketch the equation y equals negative 5x plus 4. That corresponds with the inequality, and both of them will use a solid line since we have that less than or equal to. We also know that the parabola would be facing down because a is negative. So I went ahead and I just used the one from the book, but that would be the sketch of the parabola. Step 2 then would be that we need to test a point. So 0, 0, the point 0, 0, does not lie on the parabola. So we can go ahead and use that. So 0 is that less than or equal to a negative 0 squared, which is 0, minus 5 times 0, which is also 0, plus 4. Is 0 less than or equal to 4? That is true. So because that is true, we want to go ahead and shade the parabola on the inside. And that would go for step 3. You can see the similarities to when we were doing linear equations. You check to see if it's a solid or a dashed line. You test a point to then decide if the shading contains that point or not. The second goal of this lesson is using the inequality in real life. So we have a bridge building in Japan. It's the longest suspension bridge in the world. The shape of the main cable between the two main towers can be modeled by, and they give us a formula there, where x is the distance in meters from the center of the bridge and y is the height in meters above the road. So they've asked us how high are the towers above the road, and they've also asked us to write a system of inequalities that describe the region under the main cable, above the roadbed, and beside the main towers. Assume that the roadbed is modeled by y equals 0. So first of all, we need to graph the equation. So the diagram shows that the distance between the two towers is 1,990 meters. Because the vertex of the parabola is at the center of the bridge, the x-coordinates of the tops of the towers are plus or minus 995. So it says substitute either value. So we have, first of all, and where did we get that? I needed to go back here just a second. We have the formula. I guess I have everything there. So we're going to go ahead and we are going to substitute the 995 into our x squared. When we do that, sorry, I thought I had that copied. From the book, we would end up with, I'll just type it in here real quick. We would end up with y is going to be approximately 201.12. 201.12. So the towers are about 201 meters from the road, above the road. Just substituting in our 995 for x. Maybe I'll type that in there real quick for you as well. So we would have y equals 0.000188 times 995, and then that would be squared. And then we are going to add 15 to our, that was our original formula. I've substituted the 995 squared in, and we will end up with approximately 201.12. To figure out the other parabola, the parabola y equals 0.000188x squared plus 15 opens up. So to include the region below the parabola, the main cable uses a less than or equal to. So then you'll see that shading outside of that main parabola. So the region below the cable would be this formula. The region between the towers is going to be this, and the region above the roadbed would be this. Again, substituting that in, and we can find then our shaded area.